This is free response number 5 from the 2019 AP exam. I've posted it on Schoology if you need to take a look at it. It's also searchable online. I thought this had some nice review things in it. So they ask us, first of all, to find a value of k that will make the slope of the tangent line equal to 6. So, of course, we need to take the derivative of this function. And you could use a quotient rule, but I think if you write it with a negative exponent, that would probably be the easiest way to deal with this one. So I'm going to write this as x squared minus 2x plus k to the negative 1 power. So the derivative is going to be equal to negative. Inside function stays the same. Remember, you drop the power by 1, so it's going to go to negative 2 power multiplied by the derivative of the inside function. It's got a sum in it, so make sure, actually a difference, make sure you've got parentheses on that. And we would like f prime of 0 here. I would probably rewrite this as quantity 2x minus 2. Actually, let's make that quantity negative over the quantity x squared minus 2x plus k to the second power. And if we're subbing 0 in here, of course we can do that. And what are we going to end up with here? We're going to end up with a negative 2, which is 2 on top. On the bottom, we're going to end up with k squared. We want the whole thing to equal 6. So we can cross multiply here, and 6k squared is going to equal 2. K squared is going to equal 1/3, 2 over 6. Now be careful here. Normally you would have a plus or minus, but if you read the question real carefully, they said they only want the positive values. So k would be radical 1 over radical 3. You can rationalize, but they don't make you do that on the AP exam, so you can probably just leave it in that form. And again, we only need the positive one there. Okay? We'll check the scoring guide on that later. Part B. All right, Part B asks you to find the value of the integral between 1 and 0 of this. And notice a lot of these reciprocals are natural logs. This one is not because, well, you don't have the derivative of the inside function up top, so we can't reverse the chain rule here, which means this can be not separation of variables, this can be partial fractions, okay? So I'm going to rewrite this integral as, notice they give us a k of negative 8 here. With k being negative 8, that denominator will factor. So I'm going to do a over, I'm going to do an x minus 4 plus b over, let's see, that's going to be an x plus 2, and then technically dx. I guess really we should have a big set of parentheses here. Anyway, remember how this works. You can do the long version here, and you can get common denominators, and you can match it up with 1 over x squared minus 2x minus 8. Remember, there's also the cover-up method, which can be a little bit faster. You write this as 1 over x minus 4 times the quantity x plus 2. You can set it equal to a over x minus 4 plus b over x minus 2. And if you remember, Heaviside says you can take the value that would make that denominator 0, which in this case would be 4, okay? Cover up the part of the denominator that would be 0, which of course would make it undefined. And interestingly enough, if you sub that 4 value in, that whole expression should evaluate to whatever a is, okay? So in this case, if I put 4 in here, I'm going to get 1 over 6. So my a value is 1/6. For b, I can put 2 in for x, so I have to cover up this part and put in 2. Notice if I do 2 minus 4, let's see, I think I messed up a sign here somewhere. If I put in a 2, oh, I'm sorry, that's an x plus 2. So we put in a negative 2, and that's going to give me a negative 1/6 there. Okay, so what we end up with here is the integral of negative 1/6 times the quantity 1 over x minus 4. We're going to be able to factor out that negative 1/6 dx plus the integral of, oh, I'm sorry, that's positive 1/6, man, I'm being lazy here. Negative 1/6 times 1 over x plus 2, and we're taking the integral between 0 and 1 for both of these. And then unfortunately, we got a lot of simplifying to do. This is going to be 1/6 times the natural log of the quantity x minus 4. Make sure you've got that absolute value on there. And we're going to be evaluating it between 0 and 1. And then this one here is going to be negative 1/6 natural log of the absolute value of x plus 2. And we're going to be evaluating that between 0 and 1. And anyway, you should be able to pop everything in here. Remember, you've got an absolute value here. So 1 minus 4 is negative 3, but you're going to make it positive. So that'll be 1/6 ln of 3. You're putting 0 in here. That's going to be 1/6 minus the ln of 4, okay? And then we're adding this whole second one over here. If you put 1 in there, that's going to be negative 1/6 ln of 3. And if you put 0 in there, it's going to be minus 1/6 ln of 2, okay? If you want to leave it in that form, I believe they'll give you the answers there, or they'll give you the points for that. These do cancel out, so you've got a negative 1/6 ln of 4 times the quantity, is it plus ln of 2 there? I think it was supposed to be a minus ln of 2. I think I've missed a sign somewhere here, because I believe the final answer is going to simplify down to negative 1/6 times the quantity ln of 2. Again, I would probably just leave this version up here, except maybe cancel out the one part. Let's go look at the answers, because I think somewhere I've missed a sign. All right, part A, 3 points for that in part A, which we got through with flying colors. The second part here, let's see, 1/6 ln of 4. They set this up a little bit differently than I did. Let's see, 1/6 x over 4. I've got that. We've got negative 1/6 x plus 2. We've got that. And then we're evaluating, I guess they put everything into the same fraction. So they're putting 1 in for everything. You get a 1/6 ln of 3 minus 1/6 ln of 3, and those cancel. I got that. And then we're getting a 1/6 ln of 3, negative 1/6 ln of 4, got that, and a negative 1/6, oh, it looks like I missed a sign here. That should be plus a 1/6 ln of 2. Oh, yeah, I had that right. That was a negative there, and I lost the negative there. Anyway, this should work out to be negative 1/6 ln of 2. Somewhere in there, I think I messed up a sign, but you can go back and check my work carefully. Anyway, general idea, though, is correct. Let's move on to the final one. The final one, we'll look at the answer first, says for k equals 1, find the value of the integral from 0 to 2 of f of x, or show that it diverges, okay? In this one, that factors as 1 over the quantity, it's going to end up being 1 over the quantity x minus 1 quantity squared, okay? And they're asking you to find it between 0 and 2. And on the surface here, you think, well, isn't this just the same thing as what we did before? But you have to be real careful here. First of all, I think we're going to be able to integrate that with the power rule, because the derivative of the inside function is 1, just the way it factored. The second thing here is this thing is undefined when x is equal to 1. And so I think we're going to end up with something where maybe it's doing this kind of thing where there's an asymptote or something at 1, and we have to find out, will it approach a limit or not? So this is an improper integral, okay? And remember, the idea is you break it up into parts. So you can take the integral from 0 to 1, and then you can take the integral from 1 to 2 and kind of break it up. So integral from 0 to 1 of 1 over x minus 1 squared dx plus the integral from 1 to 2. And technically that's 1, it's kind of the left-hand side of 1. This is kind of the right-hand side of 1, I guess, is really what we're doing here. And this is 1 over x minus 1 quantity squared as well. All right, that's x minus 1 to the negative 2 power. So the integral of that should be negative x minus 1 to the negative 1. Okay, I wouldn't leave it in that form. I'd probably write it as negative 1 over x minus 1 if I was going to try to evaluate it. And we're trying to evaluate this. Remember, you can't evaluate. This is not going to evaluate at 1. Okay, so we have to evaluate from 0 to, usually we say something like b, that sort of thing. And we're going to take the limit of this as it approaches 1 from the left. So we're going to take the limit as b approaches 1 from the left of this. Okay, that's our first integral. If our second integral over here, same kind of thing. I don't need the integral symbol here, do I? The antiderivative is going to be negative 1 over x minus 1, same thing. again, we're evaluating it between two different values here. Starting from 1 on the right, so this really should be, again, we're taking a limit. I'm going to use a value here. I guess I'll call it b again. As b approaches 1 from the right, we're approaching from b to 2, okay, because we can't evaluate it at 1. So anyway, long story short, if you start substituting things in here, you're going to end up getting the limit as b approaches 1 from the left of -1 over x minus 1. Now, if you put 0 in here, you're going to get just a +1, okay? And then over here, same kind of thing. You've got the limit as b approaches 1 from the right, and, oh, I'm sorry, I should put the b in here. Sorry, we're slipping a b in there. B approaches 1 from the right. We're going from 2 down to b. So we can put the 2 in there. And that's going to be -1 over 2 minus 1. It looks like it's going to be -1. And then the last part there, we're subtracting the limit as b approaches 1 from the right of -1 over b minus 1. Anyway, long story short here, if you put a 1 in here, you're going to get a -1 over 0. That is not indeterminate, okay? That is approaching negative infinity. Negative infinity is not really considered to be a limit. So we're basically going to get that this limit does not exist, and I think you're going to get that this limit does not exist as well. Let's see how they, and so basically this integral is going to end up diverging is the conclusion, okay? So if you come down here and you look at the bottom, let's see if I can get this to focus. We can see that that's the kind of thing we've got going on here. So they show this pretty substantially. It's interesting here, they basically just say that that limit doesn't exist at that point. And actually, they don't even evaluate it at, oh yeah, they do evaluate it at 1 and different values there. So anyway, but that's the overall conclusion there.